Hi friends, hello everyone, welcome back to Tanmaya Tutorials. So in this video I have bring you some important concept where I'm gonna explain you about some classifications, and also I will help you to write some structures. So which is I'm talking about is the carbohydrates. So this carbohydrates, today let me explain its classification, and also let me take one of the example, that is glucose, and let me show you the how to write the structure of glucose both in the Fisher projection as well as in the haworth structure. So without any wasting our time, let's get started. So first of all, we must know what is meant by carbohydrates, right? See, my dear students, carbohydrates is one of the biomolecule. We know that biomolecules, we have carbohydrates, proteins, nucleic acids, lipids. Okay, so like that. So this is one of the biomolecules. Okay, carbohydrates are one of the main nutrient of your body and which will use us for the energy. And this will provide some quick energy because your body can break down into glucose very easily. Okay, that is why carbohydrates are very important. So what is the composition of these carbohydrates? Usually they are made up of the carbon, hydrogen and oxygen. Okay, carbon, hydrogen, oxygen, this is one of the organic molecule. So now let us understand its classification. So we have classified these carbohydrates into three main basic types, that is monosaccharides, disaccharides and polysaccharides. So why we have classified these carbohydrates means, see, based on the process or method of hydrolysis we have been classified. What is meant by hydrolysis means, see, breakdown. Lysis means breakdown, hydro means water. So we are breaking down one of the compound or any of the compound in the presence of water itself is called as hydrolysis. So we are taking this one carbohydrates and we are putting into the water, it will get hydrolyzed. Okay, so after hydrolysis, how many simple sugar units we are getting, right? Based on that we have classified this. Okay, I think hope you understand. So if I hydrolyzed, if I get only one sugar unit, then it is called as monosaccharide. So if I get two sugar units, I'll say disaccharides. More than two sugar units if I get by hydrolysis means, then I will say it as polysaccharide. So now let us see which are the different type of sugar units which comes under these categories. Monosaccharides, we have this glucose, fructose, galactose, mannose and ribose. Okay, my dear students. So next let us see about the disaccharides. So under the disaccharides, so which are the examples that you must know is the sucrose, maltose and lactose. So sucrose, so disaccharides, I already said that it is having the two sugar units, right? So which are those two sugar units? Let me say that. Okay, so can you observe your, so yes, the sucrose is made up of glucose and fructose. Okay, so where are these glucose and fructose? They are the monosaccharides. So those two combined to form the disaccharide sucrose. Okay, and next is a maltose. So maltose is made up of combination of the glucose plus glucose only. Two similar units has been combined. So next is your lactose, which is also called as a milk sugar, remember. So which is combined, that is the glucose and your galactose combined to form the lactose. Okay, this is important, remember it as milk sugar because it is mentioned in your NCERT textbook in your biomolecules chapter. Okay, and next I said about the polysaccharides. So my dear students, see, under the polysaccharides we have once again divided into two types. One is homopolysaccharides, another one is heteropolysaccharides. The name itself says that homo means what? Similar kind, which is nothing but so many similar kind of a monosaccharide unit combines to form the polysaccharide. But in the case of heterosaccharides, so many types of monosaccharides combine to form the polysaccharides. So let us see some examples of both the things. Okay, so that you must know about it. So homosaccharides, where I have the example of starch, cellulose, we have the example of cellulose, and also we have the example of glycogen. Okay, glycogen. So these are the homosaccharides, where these three are also made up of the chain units of the glucose. Glucose is a monosaccharide, so it is combined to form these three things. Another one, we have the example called as inulin, not insulin. I'm talking about inulin. So see, my dear student, another one thing I have to say, insulin is there, no, it is the protein. Okay, insulin, you know that it is a blood sugar level controlling one of the hormone. Hormones are usually protein in structures, but what I am saying is insulin, not insulin, it is inulin. See, this is very important topic I'm saying, so there is no need of saying that point in this particular concept, but I'm saying you because I want to link with each other such that you will remember everything. So I'm talking about inulin. This is a carbohydrate, but the insulin, let me write here, okay, but insulin is a protein, okay. But carbohydrate, so what I talking about, inulin is a carbohydrate. Two different biomolecule, no relation at all between that, okay. So inulin, so this is made up of chains of fructose, okay. Fructose is what, my dear students, it's the monosaccharide, right? So it is made up of chains of the fructose, okay. Next we have the heteropolysaccharides. So I just give examples, okay. So heteropolysaccharides, which includes the heparin, we have the hyaluronic acid, okay, hyaluronic acid we have, and also we have chitin. Do you know this chitin? It's a exoskeleton, right? Chitin is a exoskeleton that we have learned. You will be learning in that in biology, okay. And heparin is also agent, blood clotting agent, I think, and take a screenshot of it, which will be very useful for you people while you're learning. See, why I just give you this is, whenever you're learning some of the concepts, first know its basic things, then you will be like you will get very stronger in that concepts, okay. So this was about the classification. Now, as I told, let me show you the how to write the structure of glucose, both the Fisher projections as well as haworth structure, okay. So to draw the structure of glucose, first you have to know its molecular formula, right? So glucose is nothing but basically everybody knows that it's because we are learning it from high school, that is C6H12O6, right? So this is the basic formula of the glucose, C6H12O6. So let us see how to write this thing, okay? So always we were writing glucose means we will be writing this type, okay, but we have to write in the form of Fisher projection and our structure. So now let us write about that, okay. So how we will write? So this is a molecular formula, and also know while writing the structures, so a glucose is having 5 hydroxy group, okay. So 5 hydroxy group will be there, and one we have the aldehyde group. Basic things that I'm saying, okay. So first let us draw its Fisher projections. So to draw the Fisher projections, what is the easy thing which I will say for you people is, first draw the 6 carbon. So we have the carbon, 6 carbons, right? So draw the 6 carbon, how I am drawing. So 1 2 3 4 5 6. So this is a 6 carbons. You have to write it in a straight manner, not cross manner. So after that, what you have to do is, the first group, what will be there? Now the first carbon atom is having its aldehyde group. That is nothing but a double bond H. So this is a aldehydic group which is present. Then later on we have to write the OH groups. No, so we cannot write anywhere the OH groups. So how I just say systematically, only you have to write the OH groups in the first carbon atom, okay. So this is second carbon atom where OH should be present on your right side and hydrogen in the left side. And in third carbon atom, OH should be on the left side and the H should be on the right side, and in fourth carbon atom, OH in the right side, hydrogen in the left side, and fifth, OH in the right side, hydrogen in the left side. And the last thing you can write, okay, however you required. So usually we will write it in the So that is we don't care about the last carbon atom to write in right side or left side. Usually we will write it as CH2OH. Okay, because this why I will write like this, I will say you later. So this was about the Fisher projection. So how to remember left side, right side? Don't be get confused. Very easy. For third carbon atom, so this is your third carbon atom, 1 2 3 4 5 6. So in that particular carbon atom, in third carbon atom, you have to write the OH on the left side, remaining everything write the OH on the right side. That's it, my dear students. Your Fisher projections is completed here. This is the glucose structures. Okay, so but you have to now we have to write about the haworth structure, right? To write the haworth structure, we must also know one more concept called as alpha D glucose and beta D glucose. Let me explain you this concept also, alpha D glucose and beta D glucose. Okay, what is meant by see this is meant this what is this means is what happens is, let me so you know this, right? This is usually basic glucose structure Fisher projection that I have shown you now. Okay, so in this what happen is, so here we know this is oxygen, right? So oxygen is an electronegative element, so which will gain some of the electrons. Electron cloud will move towards the oxygen, which will become electronegative. I will write it as minus, and carbon will take the positive charge. Similarly, here in the last second carbon atom, that is in the fifth carbon atoms, what will happen is same procedure takes place. So your oxygen will get negative and your hydrogen will get some positive charge slightly. So what is that? S is slightly positive, slightly negative, not completely positive and negative. So what happens is here, your negative oxygen will attract the positive hydrogen, and negative here that particular positive carbon, okay, positive carbon will attract the negative oxygen which is present here. Did you understand? So oxygen attracts the hydrogen, and this oxygen attracts the positive carbon like this. Okay, so after this what will happen? So connection will be taking place. So before writing the haworth structure, this one I have to explain you. Okay, so that is what happened is, let me show you. Okay, so that is carbon 1 2 3 4 5 6 carbons as attachment will takes place. Okay, so here this OH is there, no? This I'm writing this carbon. Okay, so OH will be there on the left side. So what I said, the attractions taken place, that is the oxygen, that is C double bond O, that will be connected to this particular carbon atom like this. So this is a normal OH what we were writing. Okay, so this is third carbon atom. OH will be there in the left side, fourth carbon atom, fifth carbon atoms what we have attached here, and this is usually CH2OH. Okay, so what I said here, oxygen is attracted to, towards hydrogen. That is what happens here. O bond is created between here. Okay, so here what it is left, hydrogen is left. So the oxygen which was present, so see here is oxygen, right? That oxygen goes here. Okay, so one water molecules will get loosed here. So here oxygen was there, no? So double bond oxygen, it will get removed, double bond will get removed, and whatever left is OH. So that OH will be present here, that OH is there. Okay, so one H molecule, and here OH molecule, H plus OH is H2O. So water molecules is lost. So remaining is your oxygen. Okay, will take bind with this. Okay, like this it will get bind, so to form the bond. So this is only used to write the haworth structure. Okay, so this is called as a beta D glucose. Actually we don't show like this beta D glucose. Usually we will write, okay, like this. Okay, which means your OH group is there, no, that should be present on your left side, then it is called as beta D glucose. And similarly the same structure is there, but this OH group, okay, let me show you, let me write and show you. See, 1 2 3 4 5 6. Okay, so last carbon is CH2OH only, there is no difference in that. So here OH group is, you know, it will be on left side. Okay, so bonding will be here, the remaining obviously hydrogen will be there. Okay, here also hydrogen will be there. Okay, so the bonding will be taking place. So this is second carbon atom. Only in third carbon atom we have OH on the left side, remaining everything on the right side. Okay, I think you know this one. Fifth carbon atom, leave this for the attachment. OH, H. So here H is there. So the oxygen and carbon combines like this to form this type of bond. Okay, so this is called as, this OH which is present on right side is called as alpha D glucose. Okay, my dear students, this is how alpha D glucose, beta D glucose came right now. I think hope you understand this structure which I have explained you. So now let me show how to draw the haworth structure. This is the Fisher projection. So now let us draw the haworth structure. So by seeing this glucose structures only, let us write the Haworth structure. Okay. So our structure, we let us write both alpha D glucose and beta D glucose. Let us see this only, and I will make you write. So I have to say you the trick how to write. No. So the trick behind this is, whatever the carbon you see on your right side, you have to write that downside, downwards. Okay. So remember. Okay. So right side OH group, hydroxyl group, you have to write it downwards, and the left hand side OH group present is, we have to write it upwards. Why I am saying this one, let me make you understand. The Haworth structure of glucose is taken by the pyron structure. Okay, Haworth structure is taken by the pyron structure. Okay, that pyron structure is like this actually. Okay, so by taking the structure of this only, by taking it as an identity, like that only, glucose structure has been drawn. Okay, how it has been drawn, first let me write. Obviously we know that glucose is a 6 carbon molecule. So 6 carbon molecules means I have to write hexon here. So hexon, how you will write the hexon? You will write the hexon like this: 1, 2, 5 and 6. Okay, this is a hexagon structure, and write one of the circle here because to show the oxygen attachment. Okay, so this is how you have to write the hexagon, and draw a straight lines everywhere on the edges. Okay, like this. On the vertex side you have to draw the lines like this. Okay, and what I said here, whatever the OH group present on the right side, you have to write it downwards. Whatever the left hand side is there, you have to write it on the upwards, I said, right? So here first let us see about the first carbon atom for the beta D glucose. So the OH group is present on the left hand side, so we have to write it on the upwards. So this is you have to write upwards. So remaining is hydrogen group. So next is present on your right side, you have to write it on the downwards. So like this you have to write. So third carbon atom, always it will be present on the left side in the sense it's a, you have to write upwards, that is inside. Okay, then downside is hydrogen, remaining is hydrogen. Next on the fourth carbon atom we have the OH on the right side. Right side means you have to write it on the downside, so that is downward. So remaining is hydrogen. So remaining thing is last carbon atom. Obviously you will write the CH2OH upwards. Okay, and then you will write hydrogen downwards. Okay, so this is how you have to write the things. So this is the Haworth structure of the glucose. That is what glucose? Beta D glucose. Beta D glucose. Okay, my dear students, I think hope you understand. So that is the OH group which is present on the upwards, that is called as beta D glucose. Now let us see, write similarly alpha D glucose. Once again I will teach you, carefully listen. Obviously you will write the hexon. Okay, hexon like this you will write. Okay, so sorry, hexon is not proper. Okay, then what you will do, you will put one of the circle here, draw the lines on every vertex, and OH is present on the right side, then you have to write it on downwards. You will write downwards like this, remaining hydrogen. OH on right side, downwards, and hydrogen. OH on the left side, upwards, and hydrogen. OH on the right side, downwards, and hydrogen. Remaining a thing you will write CH2OH and hydrogen. So this is the structure of alpha D glucose. This is the structure. So this is how This is how we wrote from Fisher projection. So see, I have written everything in a one page, not only one page, it's half page actually. So everything that was say a single page I have covered. This is because you must easily identify which is Fisher projection, which is Haworth structure, and how to write Haworth structure from Fisher projection. So to know that only I have written this, and also I have explained all the different categories of carbohydrates. So that's all for this today's video. I think hope you enjoyed this video and understand all the concept which I said you. So meet you in the next video. Until that, stay tuned.